Hey, John Gilroy here. If you walk into a room of software developers, stand up in a chair and say code review, the room will empty real fast. Today, a better way. Hit the music, Manny. Welcome to the Federal Tech Podcast, the podcast that connects you to federal technology leaders. My name is John Gilroy, and I will be your moderator. Our guest today is Nathan Jones, Vice President Federal at Sonar, Sonar. Even I can spell that, Nathan. Pretty good, huh?
Wonderful. Yeah. A good Navy technology.
Yeah. So why don't you go find a room full of developers and stand in that chair and watch them run out of the room? No one likes code reviews, but, when they do surveys, the software developers say it's a good idea. On the other hand, so we got this push and pull. Federal government's got tons and tons of code needs to be reviewed. And what's the best way around that? I think maybe better than putting a new motor in your car. If you change the oil every 5,000 miles, it may last a little bit. So that's what we're going to talk about today. We're going to talk about secure software design, what the federal government has to say about it, and where Sonar fits in the perspective. So let's jump in here. Tell us a little about what Sonar does for the federal government, Nathan.
Yeah, the challenge you talked about is code is being developed faster than ever before. So that car that you talk about needs lots of new capabilities. People have expectations from, all the different online companies as well as opportunities and apps that they want new features, and they want features to come fast into federal government applications, whether that be for the warfighter or for citizen-facing applications. The challenge is to do that with the federal government in a very, very secure way. And this isn't new. Security requirements were placed on federal contractors, going back ages, right? But it used to be that you got this big system from one integrator, and they did lots of waterfall type testing and process and reviews. Now things are much more modular. So you need software that will inspect the pieces and help the developer, because you don't want, as you said, code review to be a burden. You want it to be like a spell checker. And in fact, that's some of the capability that we drive is, using the capability that when they're developing the code, the developer can see right away that they're writing something that is either duplicative, problematic, or an error, right? And so the more you build that in, the better you make their experience, and the earlier you find the bugs and issues, the cheaper it will be to fix that, right? So there's a huge problem out there in terms of code quality issues. We believe at Sonar that can be best fixed earliest in the process. And that's what you and I talked about in terms of shift left, right? That's how we explain that.
Okay, here's the numbers. These are pretty impressive numbers. Sonar, 30 programming languages, 400,000 organizations, 7 million developers. You should have a T-shirt or something like that. That's kind of like bragging rights, huh? 7 million, that's a bunch.
Yeah, most developers have used the Sonar Cube project. It has been out there for over 15 years, and most are familiar with it. Now, what we do is try to educate folks about all the different capabilities that are available, right? Many people use it a little bit, and we want to help them use it in a very effective way with reporting and with all kinds of additional rules that they can implement and enforce policies across lots of different things. So making it more programmatic, but Sonar Cube, the technology, has been around and is used by millions of developers. It is the most popular, quality assurance tool out there. Again, loved by developers. So you joke about the code quality thing and people hating it, but people like using Sonar. It allows them to fix it better. It allows them to cover that code better. They talk about code coverage. And if they have to do it, you might as well do it with something that makes it better, allows them to move on to the really cool stuff. They want to build features and functionality. And what we do is help them check their code as they're doing it in the most effective and efficient way.
It's really so human. It's this push and pull. They don't like code review. However, and here's a study they found this morning, 2022 Global DevSecOps Survey, 70% of developers said code review was very valuable. So they know it's valuable. I've got to get up and do my push-ups in the morning and run 5 miles because I'll be fit. And so they just will complain while they're doing it. But this can help them, can't it?
Yeah. Well, and there's a lot of numbers out there, as you said. You cite that survey, but there's also a lot of discussion about the cost of that bad code. and it's in the trillions, right? And so Jen Easterly, the director at CISA, talks about that and talks about how, again, it's a multi-trillion dollar problem that we have to fix. And so developers know that code review is important. And one of the reasons they sometimes will like it is they like it better than when vulnerabilities are found in security reviews months later, years later, and then come back to them to be fixed, right? A developer would much rather do the code review and fix it when they wrote it and when they remember what they wrote and when they know they can fix it in a faster way than having something out there and coming back to them over the wall from all the security and operational tools that folks have on the infrastructure side to measure that. So again, they don't like it. They want to create new capability, but tools that are implemented into the development framework and are easy to use will increase that quality, get you to do it faster, and avoid them getting these issues thrown back over the wall months later when it's a lot more expensive and a lot more problematic to fix.
You mentioned CISA. I'll give you my favorite quote from CISA. Here's a quote. Every technology provider must take ownership at the executive level to ensure their products are secure by design. So you're not the lone wolf talking about this. This is what leaders at CISA are talking about. This is what, you go to a manufacturer in Chicago, they're talking about reducing cost and being more efficient. And I think the phrase that pays in this new administration is going to be efficiency and how can be more efficient at writing code. And this is the best way to do it.
Yeah, to me, secure by design is, it's a pledge and folks have signed up to it. And it's bringing the attention to the problem in the commercial industry. But if you look back, we've had other initiatives under the last Trump administration. That's when CMMC came out. If you look at the fundamentals of CMMC, of secure by design, of a lot of the cybersecurity initiatives that have come out more recently, and the executive orders like Executive Order 14028, all of those fundamentally look at how have you built the components that you're introducing into the mission, right? And secure by design and CISA, they care about, the entire, U.S. infrastructure. CMMC more focused on the DoD community. But at the same level, they're all looking at, have we introduced components that are trusted? So we know that they all work together. Because again, moving from those monolithic systems that were built by one entity to systems that are interconnecting a lot of very cool capabilities and constantly innovating, constantly changing, you have to have a way to inspect the components. And that's what they're saying, right? They're talking about observability, they're talking about security, but our piece of that is really the first piece, which is when you're building it, build in the security. When you're designing that software, absolutely test every component. And again, the rapid pace of development these days makes it more and more important.
Yeah, baked in security. I'm in the classroom a lot, and I remember 2 or 3 years ago, one of my students was from Deloitte, handed me the business card, had CI on it. I said, continuous? Like every day? Well, it's continuous. And so this is just a phrase that people toss out, but I don't think people realize that, well, what if, if you improve something and it you underestimate or overestimate the impact? It's so, boy, having some kind of regular processes. We talked about changing oil in cars, but another image that came to me was pouring concrete. Put down the molds, put down 4 inches of concrete, take the molds away. You go, uh-oh, Nathan, we forgot the XYZ. And you have to jackhammer it out. Believe me, no one wants got a jackhammer with concrete. So in many ways, all these systems, because once they're designed and once they're approved at a certain security level, it's almost like concrete. It's hard to make those changes. And if you have it baked in, that's all good in that way. So a topic that's thrown out here is open source. So where does open source fit in this whole discussion?
Yeah, so I'm a big open source fan. I worked 20 years at Red Hat before coming here. And that was in the very early days of introducing open source to the federal government. So open source today is widely used and is the design method of choice for developers, especially in a lot of the innovative areas, because open source is a faster way of developing. So you talked about those building blocks. You talked about the way that you can put together components. That is generally what open source is about. But it's also about everybody being able to see that code as it's being developed. The beauty of that is that you have many, many eyes looking at the code and possibly creating much more quality deliverables and learning from what another developer has done and being able to bolt on to it instead of starting from scratch, right? So that allows us to springboard innovation. That's why almost all of the cloud computing is done in and built with open source software. Now, people can also look at that and say, you can introduce an open source project very, very quickly. Somebody can invent it, introduce it into the world, and how do you, as a consumer of that, know that it's secure, right? And that's where you have to really inspect that code. The goodness of open source code is it's very easily inspectable because it's open. If you go to a proprietary company and you want to inspect their code, you have to work with them to actually see it. There's a limited number of people who can see that code, touch and feel it. In open source, anybody can touch and feel it. So it has great power. And if lots of people are looking at it and working in a project, there's probably going to be better quality and the innovation is going to happen faster. If it's a project that only few people care about, then you really have to look at, how do I now test it? How do I now inspect it? But you can say that it's very easy to inspect if you have the right tools. So that's where we come to play. One, Sonar Cube, our product, is built in open source. It is an open source tool. At its heart, the core of the product is open source. It's a project that was started many, many years ago. But we also do a great job testing and looking at open source tools that customers are using. Because if you're going to, a developer in federal in some mission program may develop a weapons system. They may develop that using their own code, but they're going to pull in some reusable components from the open source community. That's great because it's reuse. A lot of the security documents we talked about there a few minutes ago point to reuse of things that are proven, right? Those proven things can easily be open source and then can be used by many different programs around federal. The key is just making sure that open source is curated, that open source has been tested. So you take that, you combine it with the code you've built that is very custom to a missile system, but you reuse that componentry around messaging or something else that can be used on many systems. But visibility is key, and open source presents that opportunity to look at every line of code.
Nathan, it's January here. There's snow on the ground, March 12th. Let's hope we get a break. No snow on the ground. Where are you going to be March 12th?
So March 12th, as I invited you, is our first big live event. We're going to do an educational event out in Reston, Virginia. And we're very excited to, cover a lot of these topics in depth. So we urge you to come, and really dive into. We'll talk about code quality. We'll talk about open source. We'll talk about, again, some of the integrated design features we have that are built into the development of software. So not only code quality review, but also the tools we have, like the IDE tools we have that help the developer while they're actually writing code. So we'll have some live demos, we'll have some education sessions, but a great kind of user conference educational session.
Yeah. If you're listening to this and walking your dog or doing pull-ups or something, I will put a link to the event in the show notes. It's going to be at Caresoft. It's easy to find. A blind man could find it. Just walk around, it's out there, and parking's easy, and it's a nice facility, a great little place. Show up in the morning, see what's going on, and then you have a basis for evaluating this and learning so many different things. And right now I'm trying to get my handle, so what is Cube and server and cloud? So different Sonar applications, so the QUB is free and the other ones aren't, or what are the variations of programs you have?
So Sonar Cube is the project, right? And then we sell it as Sonar Cube Server or Sonar Cube Cloud or Sonar Cube IDE, which is the tool that developers will use, again, in their integrated development environment as they're writing the code. So we have both a server offering that works in any secure government environment, as well as we have a public cloud offering that's available generally for commercial customers. So it can be deployed anywhere you're using it. And again, as we talked about earlier, lots of different coding languages, almost every common coding languages, from the very common like Java to things that maybe only the federal government can have, like COBOL. We support all of them.
And for our newer listeners, COBOL is a program from the 1970s. Wow. Yeah. I mean, yeah, that's a fun note.
The
So
federal government is using old code and new code, bolting them together. In order to do that, you have to test it all. So we've worked hard, and the community has worked hard to participate in making sure we have coverage, again, for all different kinds of code.
that's good. And I think the basic principles apply to many different languages, and one principle is maintenance. So how can you be assured that if you maintain a line of code, it's not going to break something else? Or, can you be assured that it actually is going to improve the speed or maybe improve the security?
Well, one of the ways you do that is, again, you referred to this earlier, that folks are setting up these environments. You can call it continuous improvement, but there's a lot of the different environments they're setting up specifically around how you're going to develop software, how you're going to manage software, how you're going to introduce new features. So a lot of times you'll hear them referred to as a software factory, or managing the toolkits you're going to use across software development in a whole agency. So a lot of our conversations today are around helping folks with standardization of tools like ours, and then they're also doing the same thing for observability and security, so that they can, again, look at that line of code and make sure that it's going to interoperate with something else in a very effective way. And a lot of times you're taking capabilities, like I said, modular capabilities, and you're using them across multiple applications. So it may work great with, one application, but when you go to introduce it to another, it may not. Well, why is that? Well, with tools, again, you can look at exactly how that code is not only acting on its own, but how it's interacting with the other pieces of the software. So that's where you hear about these factories. You hear about people really looking at the way to build and pull applications together, pulling open source as well as stuff you've built yourself, and operationalizing the entire approach to that so it's repeatable, right? The more you make it like a factory, the more you do these things again and again in the same way on every type of code, whether it's COBOL or Java or something else, you're going to get good at it. You're going to get, excellent at it, right? And there's always going to be security things you find. Some things you find right away, some things you find later. But the more you have that factory approach, that process approach, you're going to be able to fix those things quickly, and you're going to have a repeatable way. And everybody's going to be in the same speaking the same language in terms of how they reconcile the issues.
I was doing some research this morning for this interview, and I stumbled on an acronym that I've used maybe once or twice in the past. Maybe you can tell me if it applies to this discussion or not. It's OWASP. I think it's Open Web Application Security Project. Does this apply to this conversation, or is that just for testing open source code?
So when you're a developer and you're looking at a lot of different ways to measure and reference, known security vulnerabilities. So there's that one that you talk about. There's CVEs. There's people who are building their applications to be compatible with different things. They might be building them to be STIG compliant, right, in the DoD. These are all references. Either they're security references where these are vulnerabilities that have come out, and you need to test to them to make sure that they don't exist in your application. They're known things, either known things that you're going to accept because they're a minor issue and you have other layered security to work around it, or they're vulnerabilities that you have to avoid. And so whether it's OWASP or CVE, or whether you're writing and testing your application to make sure it will pass the STIG, these are all things that you can automate in a tool like ours and report on. So what these developers are going to do is have to spit out these reports on a variety of these different things to show their security folks, hey, I built this the way you expect me to. And I built this to standards, right? Well-known commercial and federal standards. So that's where all that comes to play. But we incorporate that into our tool where you can easily see how you conform to those standards.
Yeah. And I think a demonstration on site at CareSoft would visualize what we're talking about here. It's so much more easy. We can, this is how now I see what you're talking about. That's good.
Yeah.
I go to events all the time, and what I'm going to do is I'm going to read you a quote from a major general from the Air Force I heard in December, and you can agree or disagree or, I don't know, make a comment on it. So here's what he said. The guy's name is Major General Genetempo, and he was at a conference in mid-December, a lot of people up on stage, and he said they ran some artificial intelligence on some code they were running, and they found 300,000 lines of code that didn't do anything. I wrote that number down, 300. Is this shocking, normal, abnormal, or typical? Or so I'm surprised.
Well, I mean, the problem is you have to have code coverage, right? You have to know what code you're deploying, and that problem is going to get is going to multiply with they used AI to look at that code. What is happening is there's more code that's going to be created using AI. And when you create code using AI, you're going to have code that maybe nobody's ever looked at. Now, that
Uh,
300,000 lines of code, if it was older code, was written by somebody and was probably tested by somebody, but they haven't been doing code reviews of it recently. And
yeah.
obviously it's dormant. And of course, there are tools like the ones we have that can help you see that you've got lines of code that have been abandoned, that haven't been checked in a long time, and allow you to implement a repeatable way of testing every line of code you have. um, the opportunity that's on the horizon that we have to get ready for is now we talked about developers pulling in open source projects. So those are things written by somebody else, and they're going to use them in their application. And some of them are very, very well known, very well tested. We have information on them, others have, and we know exactly what is in that. The other great opportunity out there is that AI is going to generate code. So you're going to have a set of code as a developer. You're going to be able to create a lot more code than you ever could before because you're going to deploy AI to help you write some
Oh,
of it. Now, that can be powerful.
and
You test it. Like you have to make sure you know what's in it. And you, as a developer, are going to have to attest to security folks that you've looked at it and you understand how it works. So the beauty of AI is allowing you to, again, find issues like you're talking about, the code that was unused, older code, but it's also about helping you develop and innovate and build something and anticipate capability. Now, the government's going to continue to discuss how much we're going to let folks use AI in the development process, but it will be used in some way. And there's other solutions like low code, no code solutions. So all of that needs to be, again, brought in to the software development lifecycle we talked about, to the factory of sorts, and tested, right? So that you can make sure you know what's in it, you know how it's going to work, you test a lot of different scenarios, and you feel comfortable deploying that.
now that is reasonable advice for proceeding with AI in 2025. I mean, I think people just they're dazzled, silvery shiny thing, and wait, you might want to check that. I mean, at the same event, a woman stood up and she said, artificial intelligence is always confident, but not always correct. But people get dazzled by the confidence. Wow, look how fast I did this. I never thought of this self-multiplying effort where you're drowning in code and don't even realize it. But that you can see that happening, can't you?
Yeah, I mean, it's just about planning for it, though. If you know it's going to happen, I mean, the we don't want to constrain innovation, but we do want to do it in a repeatable, high quality way.
Yeah.
So, we're going to have we need to move at the speed of industry in the government, and the way to do it is in government to make sure we're testing it to the level that our citizens and our soldiers expect, which is that it is something we can really rely on. So like you said, it's like it can't be something that we incorporate and we haven't reviewed it. So again,
Yeah.
quality at the beginning is essential. And if you use the right tooling and the right, again, repeatable process, the right factory kind of process, it's not going to hinder the developer. In fact, hopefully it's going to help them with suggestions, right? So part of the other capability we have is more curated advice, where as you're writing the code, it'll give you a suggestion on something that is a better option for security or a different option,
Yeah.
maybe a couple different options. So again, that's a way to build in that code review, but do it while they're building the code so that it becomes part of the process. And I think that the folks who have just used our software or other softwares to just test it after they write it aren't utilizing the full potential, right? The things we've talked about today that you and I have talked about today
Yeah.
is automated reporting about these standards and how I conform to them in the code I just wrote, or suggestions as I'm writing the code that pops up and says, you might want to do it this way. Those things can really help a developer make code quality efforts, fun, make them fast, make them not a chore, but rather a helpful part of their daily job.
Yeah, we start off with code review. We're going to end with code review. But I think if you have you considered, that's much better approach than do this, Nathan. Have you considered this option? I tell you, that's working with humans. That works.
Yeah, and I think that the developers will agree that they'd much rather do it themselves than have security folks throwing the code back at them months later and saying, hey, we found this problem.
Yeah.
You want to own your own problem resolution. You want to have be leading there as development. So I think that there's a lot of empowerment to come. The whole factory process, the way that we're building software today is faster, more modular, and that's empowering the developer to have a great seat at the table. So again, I think that Jen Easterly's comments and several others about secure by design and building things in from the beginning is great, and it's an approach that empowers the developer. It doesn't give them chores of here are the 20 problems we found. It's empowering them to do things differently from the start and make that job even more critical than it is.
Great. This has been a fun interview here. You have been listening to the Federal Tech Podcast with John Gilroy. I'd like to thank my guest, Nathan Jones, Vice President Federal at Sonar.
Thank you, John. It was exciting to be here.